We are here live for our third session of the day. Welcome to the summit. I'm Nikki Gonzalez. I'm going to be hosting this conversation over the next 45 minutes about IoT initiative scalability and security. If you don't know me already, my name is Nikki Gonzalez. I am the head of partnerships at QuoteBeam, as well as the co-host of the podcast Automation Ladies. And although I am more on the industrial automation side of the house, oftentimes I have quite a long history in IoT, starting with working for my dad's company when I was in middle school. So I'm pretty excited to get to talk to a couple of experts today about scalability in IoT initiatives and cybersecurity. So today I have with me Jeremy Friedmar, who is a director of product management at Belden, as well as Scott Coleman, a VP of product management at Owl Cyber Defense. How are you guys this morning?
Good. Very good. Thank you.
Great. Thank you so much for joining me. This is a pretty cool topic, and we've had a couple of conversations, but I'm really excited to get into it and talk about some of the angles of how we can scale and securely with a lot of these IoT initiatives that have been, over the past 5 to 10 years, piloted very successfully, I think, and some unsuccessful pilots, of course, in all kinds of different applications and factories. But now we're at a point where a lot of these pilots are going to full-scale deployments, and there's a lot of considerations to talk about there. And I think bringing cybersecurity and scalability together, although sometimes could be considered separate topics, can be very relevant because both are very big considerations when we talk about taking a small scale test to a site-wide or worldwide deployment. So thank you so much for joining me to talk about this. Our first question, I guess, I want to just dive right into it. How do we staff these types of initiatives when we take them, from pilots to scaling, and how does that evolve over the size or sort of the as a project grows? How does that scale in terms of also how we take our manpower? Where do we find the types of people, or do we bring them in from the outside? Can we talk a little bit about that before we start diving into the technology side? Because it's all about people in addition to technology, as we try to talk about from every angle as possible.
Well, I suppose I can start here then.
Yeah.
So let's take a step back and really give some consideration to exactly what is driving these IIoT initiatives in the first place. So there's a couple of counterbalancing effects that are at play here. The first is the fact that there is more and more data being generated than ever before. And this is, of course, through the proliferation of more connected devices, and those devices being smart. They're embedded with technologies that allow for them to connect to and exchange data with the internet. But on the flip side, these initiatives are being developed and driven in the face of some significant challenges in our world today. We've been in the midst of a major supply chain crisis, and we're also facing a significant inflationary environment as well. So really the key for industrial users really becomes ensuring that they leverage this data for the benefit of their business, while also not being undermined by the challenges that we're facing in the market. So as a result of all of these considerations, it really comes down to ensuring that the IIoT initiative is structured and staffed in a way in which they can effectively respond to these challenges. And there's a couple of ways that this can be done. First is ensuring that there is a focus on the business objective of that initiative first. And there's a couple of different considerations that come into the consideration of the objective first and foremost. One is recognizing the fact that there may very well be a need to embrace new technology. And this needs to be done in a manner in which efficiency can be made possible to counterbalance some of these challenges we see with supply chain and inflationary pressures. And then the second is recognizing that as more data is being generated and users may be less familiar with ways to effectively handle it, there needs to be an openness to embracing more of a service orientation. So rather than a self-reliance in selecting products, putting bill of materials together, there needs to be a bit more of a reliance on a service offering that can complement the product selection activities and the development of a solution that can effectively drive the IIoT initiative forward. But of course, piloting is always key, particularly in light of the fact that there's new tech adoption taking place. And more importantly, too, the fact that there is much more interdepartmental activity taking place between especially IT and OT departments within an organization. And that's actually one of the reasons why Belden, as an organization, has developed what we call our customer innovation centers, because we have recognized this need to provide our customers with a forum via a lab environment to assist our customers with the design and implementation of such pilots and proof of concepts.
Very cool. Scott, do you want to add to that from your
Yeah,
side?
I think from the cybersecurity perspective, the refrain we hear over and over is enterprise ready, right? So before you used to get data off of a couple of devices. Now with basically every device reporting stuff back, right? You have to have a much more widespread coverage of where that data is originating. And of course, you want all those endpoints protected. So when we hear enterprise ready from our customers, it really is, how easy is it to deploy? How can I keep it maintained and up to date? And so that my operating costs, right, over time don't spiral, right? And so once I get it in, know that it's working and I don't have to sort of babysit it and stuff. So that's really the area that we focus on is understanding what it takes to make it really simple to install it and keep up and running, so they don't, it doesn't become a concern. We can sort of focus on running their OT facility, their plant or whatever it is, versus, worrying about individual pieces of technology.
Okay. And do you guys, do you see that on the cybersecurity side as well, sort of a partnership with services, or at least some expertise from the vendor that, they can rely on over time, or are they fully staffing, everything to deal with the hardware and the software in-house from the time of implementation?
Yes, that's good. So typically what we see, so we do work with a lot of both resellers and distributors, right, which are typically geographically local to the part, to wherever the end user is. And they're bringing in, their installation services, their professional services, et cetera. Obviously, there's training that goes along with that. But in general, there's a sort of a blend of what they expect of their folks in terms of gaining expertise on the technology, but then relying on, especially if it's a short period of time where there's an install, right? It's hard to say I need to get fully trained to let me outsource that bit, right?
Yeah.
And I just worry about the ongoing maintenance, and I'll sort of pull in resources as needed so there's that sort of that blend of relying on the vendor, but also creating some, self-sufficiency, as you gain expertise with the technology.
Absolutely. And I think most long-term, successful projects have a sort of a partnership mentality, right? You may rely on a vendor for some services or a third party that can help you, but you certainly want to know what's going on. You want to be able to effectively communicate and work with that third party if that's the way that you structure that. And have some expertise in-house, so you're not fully relying on a service that you don't understand. But at the same time, I think it's unreasonable to say that most manufacturers at this point in time maybe have all of the resources in-house that they need to effectively deploy, support, and maintain, especially if we think about scalability, going from a pilot to full-blown system and maintaining that. They're definitely not going to maybe get as far as they would utilizing a partner for those parts where they either need those extra services or support, right?
Yeah, I would say that almost all of our customers do some kind of POC or something initially, right? Get familiar with what's going on, understand the scope and scale of what they're going to do, get it set up in their sandbox or their test bed, right? And before they go into production. So I would probably say 90-something% of the time, that's how they roll stuff out. So it's always that staged, process.
And I probably fumbled a little earlier, not fumbled, but like from my perspective back maybe 5 years ago, I was seeing a lot of pilots, right? So I kind of talked and said, oh, now I'm sure a lot of these pilots are maturing. But I'm pretty sure that there's still a lot of companies that are behind on that maturity curve. They're doing pilots now versus having done pilots 5 years ago and scaling. So let's talk a little bit, let's back it up and talk about pilots a little bit. How do you design pilots to be effective? to not end up in that, sort of dead pilot graveyard that we all hear about.
Yeah, we always try and identify those use cases up front, right? So what is the data you're trying to get to? Where does it need to get, right? What does it look like? What protocols are you using, right? Because too many times you get into something and, right, they haven't defined up front exactly what their use cases are, or the users, or who's, concerned about getting this piece of data, or whatever it is that you're moving to them. And then it just sort of goes into the black hole, right? So if you've got well-defined use cases up front and who the owners are and what data is, we've been really almost focused exclusively on that in the last 4 or 5 years, is right, just what is exactly your use case, right? Let's define those up front, get it documented, and now we know we're all working toward that same thing. So we find that is a critical element of success.
Yeah, because just like I say, you don't ever want to automate a bad process, right? You don't want to scale a bad pilot, right?
Yeah. Yeah.
Jeremy, you have any thoughts on that?
Absolutely. So I think the comment just made now about identifying that use case and using that as a way to define the criticality of the project and scope it is truly key, and the only way that success can be achieved. But the user needs to ensure that they don't necessarily get pigeonholed on that particular focus, and builds an effective infrastructure in order to build and support that use case. So granted, I know that we are at the Do More with Data Summit, and we need to make sure we effectively design a platform in which insights and value can be derived from that data. But let's not forget, we need a way to move that data in the first place. So what Belden touts all the time is the fact that we absolutely need to ensure that in order to design an effective pilot and ensure that the implementation thereafter is also effective, is ensuring that the network infrastructure is robust, both with active and passive components. There needs to be attention paid to network redundancy to ensure that there is a limited downtime and the availability for failover. There also needs to be consideration paid to real-time capability. So that way, with some of the new time synchronization protocols that have become available, that there is an effective way in which the latency within the network is managed. And of course, the network needs to be securitized, as we just talked about earlier. But it's not just necessarily about the network also. We need to ensure that users leverage open and flexible architectures. So consideration needs to be paid to interoperability, particularly within environments where there's a number of disparate pieces and parts that are very heterogeneous. Mm-hmm. And also consideration paid to decentralization, as more and more intelligence continues to get deployed closer to a user's data sources. And lastly, modularity. There needs to be effective support for moves, adds, and changes within a user's environment as well, especially in light of some of the market challenges that we talked about earlier.
Oh, absolutely. I've been living in the middle of the supply chain, crisis. I work with a lot of controls engineers, so we're talking a lot of the controls hardware. Huge challenges there in terms of, specific chipsets, specific pieces of hardware not being available. So we're seeing developments like, for instance, the introduction of the virtual PLC from Siemens, which can run on any industrial computer rather than being tied to specifically the piece of hardware that goes traditionally with that PLC, right? And kind of a merge of being able to put those OT type technologies onto more of an IT type infrastructure, particularly for this flexibility, right? And I think it's huge for robustness going forward, to help us with the supply chain challenges. But at the same time, I think it speaks a lot as well to future scalability of, plant projects. Obviously we have a starting point, right? Brownfield projects, old factories, a lot of these places have been around for 100 years or longer. They've got all kinds of different pieces of equipment that are very heterogeneous, as you say. So how, thinking about, okay, how do we put everything on a network as is right now, and think about as we change, grow, upgrade, how can we do that most effectively? There's definitely a lot of things to think about. Certainly security plays into this a lot as well. So Scott, I wanted to ask you how, coming from that security side of things, how can we secure these networks as we scale? assuming we're moving the information correctly, it's moving fast enough that we can use them, use PLC, type quick IO decision right on the edge, or where you're bringing some of this, machine learning right to the edge. If we have all that figured out, how do we make sure that we keep all that secure? Because we all know that, cybersecurity attacks are huge in manufacturing. Everybody's cybersecurity insurance is going up and going up. I know, a little bit about it. I'm not an expert, but I was, pretty excited to hear what you guys are working on with a hardware solution to cybersecurity. But I guess, how does a hardware layer for cybersecurity work? Can you talk to us a little bit about that and how that
Sure.
plays into the scalability?
Yeah. So so we use a technology referred to as data diodes. What we run into is everyone's heard of firewalls, but very few people have heard of data diodes, although that's certainly been changing in the last couple of years. It's becoming much more prevalent. A diode, I don't know, maybe I should explain what a diode is. Does that make sense?
I know what a diode is, but there might be people, I don't know who's in the audience in terms of what their background is. So why don't you
Sure.
just for it? I never
Sure.
mind hearing a basic explanation over and over.
All right. So there is one slide maybe that helps for those who are would
That
be
are visual, yeah.
Yeah. So let me just pull that up. Let's see if I can figure out how to share. All right. So can you guys see that? How diodes work?
Yeah, there we go.
Okay.
How
Cool.
work.
Maybe if I put it in presentation mode, that might be better. So there's a couple of things around diodes, right? And what the real purpose there, you can see the key to security there is that it's physical hardware versus a firewall or something that is software configurations, signatures, rules, right? And the problem with those is that they're susceptible to either misconfiguration or provisioned incorrectly, not intentionally, well, although sometimes that could be true if you have an infiltration, but that it's just susceptible to things that may not be controlled well. And so how a diode works, rather than relying on software, is all about hardware. And so at the core there in the center is actually, so for those that are sort of double E, sort of background, they understand what an electrical diode is. This is actually, and that's why at a trade show, people come up and say, okay, so I know what a diode is, right? What does that mean for a data diode? Data only goes in one direction. And it's like, yes, that's conceptually, that's exactly correct. And so there's a LED that shines light over a piece of fiber optic cable that's about 5 or 6 inches long, and it goes to an LED photoreceiver. But normally in a fiber optic, you'd have another LED on the right side there to be able to shine light backwards or to the left, right to left, in another photoreceiver. So in a diode, the most core basic element is there's a single LED shining light in a single direction to a single photoreceiver. And so the ability to go right to left in this image, right, is impossible. So the physics, right, just prevent light or data or a hacker from going into the plant, the source on the left side. So the key to the core security is in the actual hardware. So that's why there's no malware, there's no zero-day exploit or anything that can recreate the missing pieces of hardware. There's nothing that's going to spontaneously reproduce that LED that's missing. So light will never be able to go from right to left, only ever go from left to right. Therefore, data can only go that way. Therefore, a hacker could never get inside the plant. So that's the key to the security. Now, there's other things, role-based access controls, there's a protocol break, there's all kinds of things that are layered on there in addition to that core. But that, at the essence, that is the core. The thing that makes a diode work in a network, however, is about the proxies on either side, because people could say, oh, okay, I can see how you would move a picture, an image across, one-way thing, but what about TCP, right? What about Modbus? What about OPC, right? What about all these two-way protocols, right, that expect, some kind of acknowledgement, flow control, etc. And that's where the proxies come into play on either side. So if you took a basic example of TCP, so normally without the diode, the TCP connection goes from the source network on the left to the source or to the destination network on the right, and there would be normal acknowledgements and all those kinds of things that go into that transaction. When you introduce the diode, that proxy takes the place of the original destination network, and now there's a two-way communication between your source plant in the diode. And so all of the acknowledgements, all of the things that would normally be expected of the network are reproduced there. The payload is taken from those packets, sent across the diode, and then rebuilt on the other side, on the red side there, and sent out to destination. So if it was originally Modbus, it would get converted, payload extracted, sent across, and then things like like OPC, we actually act as the client on the left side, on the blue side. And then once the data moves across, we then become the server. So we can serve those same tags up to that destination, which you was getting the tags from the source network. Now it's getting from the diode. And so we sort of change roles as the data goes across. So core technology, data moves one way only, can't be hacked. We like to say in 23 years, we've never been defeated, right? Because no one can actually get through a piece of hardware like this. So there's two things that are super important: the hardware part for security, and then getting the protocol stacks on either side right. So you talk all the normal protocols that are used to move data around. Hopefully that helps folks understand where we're coming from.
Definitely. So where do you deploy these in terms of, do they have to be on, are they only on nodes that or places where data, leaves the plant, or is it internal? How many do you have to put in place?
Yeah. So that's a trend, that's a scalability question, right? Because initially, whatever you're going to go back, whatever 15 years ago, right? It was always at the edge, at that sort of demarcation point, the DMZ between your OT and your IT, right? And that's where they would traditionally sit. Now, what people are, it's funny you mentioned, right? Actually taking a PLC and running on a generic compute platform, right? That's the same direction that we're going in, because as a company, we're not, we can't scale and build computers at the same cost effectiveness as a Dell, right? Or as an OnLogic or somebody like that, whose core business is producing compute platforms. Now, our core intellectual property is the hardware diode, right? And how does that fit inside a generic compute platform? And it gets us away from the problems with supply chain. We had the same problem, FPGA shortages. We actually had to end of life products, et cetera, because of that. So we experienced that firsthand, and we're moving to that generic compute platform exactly like you described. Now, what that allows you to do is not only sit at the edge, right? But now you can move deeper into the network. You can now segment things between different parts of your network. You think about the Purdue model, right? Where you're going up layers, right? And protecting each of those layers. Well, now, if you got a cost-effective diode, you can, what we call, go out the side, right? And so instead of going from 2 to 3 to 3.5 to 4 or whatever, if you're at 2 and that's where your data source is, no one can come in through that diode. So you just go right out the side, right? And go right to that endpoint, whether it's the OEM, whether it's HQ and they're doing monitoring or whatever it is. You now have the flexibility with a more cost-effective solution to sort of deploy them wherever you want. And now you can create great points of segmentation within networks, right? Between layers, between facilities, wherever it is. And it's no longer just one sort of big system sitting at the edge. Is actually deployed more strategically. So that is what's the safety systems is a great example, right? You've got all these, inside a refinery, maybe 200 points where safety system information is coming out. And you want to protect each of those. Clearly, one way only work perfect for that scenario. And if you got a cost-effective solution, you can deploy them as needed. So that is where the market's trending to, and that goes back to the enterprise ready, because if I've got 200 in a plant, how do I maintain them? How can I, support them without incurring a lot of operating expense to do so? So that's sort of where we're going, where we see the market going.
Very cool. Can you, Jeremy, do you have something to add on scalability and security from your side of the house? And I guess, want to ask also, and maybe Scott, I'll come back to this or point this back at you now before I go to Jeremy, but how does this affect latency, or does it?
So yeah, that's a great question. Without getting super technical, the fiber, so obviously fiber optic can run really, really fast, right?
Yeah.
And we actually, because we're only moving payload across, and because we're only going like literally a couple of inches on that fiber, we actually use a modified version. If you recall the old days of ATM protocol, this was actually used by phone companies for high bandwidth, low latency, voice and data traffic. And so we actually implemented a special sort of proprietary version of that, so that we call pack the bus, right? So take all that payload, send it across, in a highly dense packet, and then unpack it on the side. So we're talking like on the order of 8 to 10, 15 milliseconds, thousandths of a second. So it's really negligible. There's basically no delay. You can run video streams simultaneously across. So that they're really, and you think about most of what people are making decisions around, right? Or even safety systems, a couple thousandths of a second, right, doesn't make a difference. We also do like historian replication, but at that point you're taking data that's already been time stamped, right? And you're moving it, so it already when that event occurred, right? So anyways, there's a big scale, and in the products do scale based on your overall bandwidth requirements, but latency is negligible.
Great. Well, thank you for that explanation.
Sure.
That really, like I said, I don't know. I'm sure most people or many people have heard of this by now, but this was kind of my first introduction to the hardware layer, the data diode. So I appreciate the diagram.
Yeah, sure. No problem.
Jeremy, you have anything to add specifically on hardware and security?
Sure, absolutely. So, I'll just kind of piggyback off of the mention from earlier around leveraging an agnostic compute platform to deploy workloads within either the pilot or the ultimate automation infrastructure. And when we talk about scalability, that is another consideration that users should take into account, and that is not rely on value generation to be relegated specifically from the hardware, but rather ensure that the installation can generate value across all of the distributed hardware and software, and even the services that are intended to support the overall implementation. And this idea of implementing a compute layer and doing more data processing at the edge is one way of accomplishing this goal. And the one comment that would be worth making to that end is a generic compute platform is not necessarily what is needed as a standalone offering, but rather the integration of edge capability into other elements of the infrastructure is also a possibility and a way to achieve the same result without an additional investment. And it doesn't just stop there, but also consideration should be taken into account with respect to scalability in terms of the setup of a secure remote connectivity solution in order to provide remote access to remote workers and such, and then also provide a mechanism for the management and orchestration of that infrastructure, both locally as well as remotely. All of these considerations need to be taken into account. And from the Belden perspective, that's what led to the development of our platform, which we call Belden Horizon, which provides that such functionality, both in terms of the remote access, as well as the management and orchestration capability of the edge infrastructure that a customer might choose to leverage.
Okay, yeah. So I guess what other considerations need to be made after pilots? So let's say that you have had a successful pilot, you've orchestrated it pretty well, you're now looking to scale. How, do you guys have any guiding principles in terms of going from that pilot to scaling, and any principles there that are not necessarily considered during the pilot, but as you start to scale, you really have to start thinking more about those things? Let either one of you jump here in on that.
Sorry. Sorry. Sorry, we want to rephrase that again, or just restate that?
What other considerations need to be made after pilots going into scaling? if there's something that, maybe isn't as critical to include in a pilot, but then once you really do start to scale, you have to start focusing on things that you haven't thought about before, or maybe just were not, in place during the pilot phase. But you really
Yeah.
got to make sure that you start addressing as you scale.
Yeah, I mean, we try and get full workloads, on the platform in the pilot phase, because you don't want to realize you don't have the right resources applied, or need to all of a sudden, okay, well, I'm going to swap out this for that, because in the real world, right, this is really what it looks like. So we try and mirror that as much as possible,
Yeah.
using full production sort of loads and environments. Maybe sometimes like an HA, configuration might be done, and maybe not in the lab. So that'd be something you might add up. People want to say, okay, we'll just get started with the basics, and then we'll move to a high availability solution later or something like that. So sometimes that we'll see that follow on. Many times what we'll see is they think, okay, this is the extent of our use cases. These are the data types that we need to use, and these are the end users. And lots of times I find, oh yeah, well, what about that other, that other data type there, that other user, they want a copy of this, or they want to see that too, right? So they just incrementally add more use cases over time. So I would say those are probably the two things that we see where people, once they get over the initial, oh, this is how a diode works. I get it now. And I see it's a little more flexible than I thought originally. I think we can add more traffic to it, more data to it, and address more use cases. And then, okay, yeah, this is actually becoming critical. How do we get into a high availability kind of, deployment? So those are the two logical things that we see on a regular basis.
All right, Jeremy, or I guess another way I could have phrased it is also, in your experience, what considerations are typically missed in pilots that then have to get addressed after the fact? And I think you pretty much, answered that question, but maybe that's another way to elicit some conversation or some answers from that one. Jeremy?
Yeah, I agree with Scott's take on that. And many of the considerations that we talked about earlier in our panel today, I think do apply as the pilot scales to full implementation. I don't think there's deviation there, which is really what Scott referred to or alluded to in his answer just before. But, obviously that addressed the technical considerations. From a manpower perspective, one item that is worth mentioning where we have seen success in organizations, particularly in light of the scenarios where there's interdepartmental activity taking place, particularly within IT and OT, is the creation of task forces, interdepartmental task forces, where there's representation from multiple facets of the organization that are involved in the pilot implementation. So that way, once the pilot does scale to a full implementation, there are representatives from all of the different affected areas of the organization that are involved to ensure success once the implementation goes full scale. So that is one recommendation that we would certainly always offer.
No, that makes a lot of sense. Yeah, because as the pilot, takes off and you start touching those different places, if people weren't involved or at least prepared to be involved, you might end up with some surprises, that's for sure, or constraints, right, that you didn't know about. What guiding principles make sense for this? That is, based on the technology that's available today, as well as maybe looking at some of the stuff that's kind of coming around the bend, right? I know this is a fast-moving area of technology. I'm sure you guys both have, some things in development at your companies that haven't been released, that haven't been out there for very long. Should manufacturers be looking at deploying, just the technology that's been available, that's available now, that just got released, or maybe something that's been tried and tested, right? Or how can they be prepared to not just pilot and scale something that they've tested, but be ready to keep that up to date, right, with the latest technology, whether that's updating some hardware with something new that's coming out, or taking advantage of new software approaches or security technologies. Can we talk a little bit about that? Being, I know we mentioned interoperability, right? Trying to have this flexibility, right? Being able to work with changes organizationally as well. But from a technology perspective, like I would be very surprised if in the next 5 years we didn't have a bunch of new technology as it pertains to this area, right? How do you make sure that as you're investing in this, that you're not getting stuck in 2023 and are going to be able to take advantage of what's coming around the bend from companies like yours or just the market in general?
So,
Do you guys have
it's-
any thoughts on that? I like to do a lot of big
yeah,
questions.
you brought up something that's like very interesting in this industry, right? Because you've got energy operators, for example, right? Once they get stuff running, they don't want to touch it, right? And
Right.
they're running the same equipment for 10, 12 years at a shot, right? So while there is new technology coming, once they get it to a place where it's stable, it's like, okay, I don't want to touch this thing. I don't want to upgrade it. Yeah, you gave me a new software release, but you know what? The features that I got is good enough. So we try and walk that balance and not sort of force people into something. But I think it's about making sure things are on par with what they have in terms of capability, right? So you don't want to jump ahead and say, well, geez, only, no one's using this, that, or because that's old, right? Well, what's old to someone is, Windows 98 or something is still out there, right? So it's about making sure that those customers that truly want an industrial solution, right? And not just a PC or laptop gets refreshed every 3 years, right? They want it in to work and run for a long time. And so I think, a long MTBF and things like that are really important in this market. Now, having said that, right, you would still want to try and drive cost out of things, right? Take advantage of the latest technologies, create more flexibility for folks so they can deploy things faster, easier, and all that. So yeah, we see is that sort of those two requirements running in parallel. I want this to run for a long time, but what do you guys got that's new, right? So so we're actually, since you brought it up, we're actually launching a whole new platform next year on 24 that is a leap ahead in terms of operating system, generic compute platforms, different cards, the use of, things like containers. So maybe some customers want to write their own proprietary filters or something, do something interesting like that. So how do you create an architecture where they could do a little, if they want to, right? Because we know many people don't want to, right? They don't want to do the build it yourself kit, right? They want something that comes ready to roll. But building in some of that flexibility as organizations mature and say, hey, you know what? We've got this one-off thing. We understand that you guys will never have that on your roadmap, but hey, if you've got an architecture that lets us adapt this and use it. So that's I think probably that's where the innovation in terms of us, our side is coming from is how do we potentially create an architecture where some end users that are sophisticated or partners, right? Some of the OEMs and say, hey, we'd like to have this capability and maybe allow them to implement that themselves. So that's sort of what we're seeing in the market.
All right. Yeah, I've actually seen that somewhere recently as well. It's a release that hasn't been made. So I'm not going to talk about it, but that is definitely, I think, a trend. And you guys are not the only ones thinking that way. Jeremy?
Yes, I really like the comment from Scott about the hesitance in our world to make upgrades. It's something that we've struggled with for decades. But one comment that I would make is I think that as we've seen this migration to virtualization and containerized applications and software-based solutions, going forward, it should make the rip and replace process much more seamless because you're not overhauling the entire underlying infrastructure. So I think that's something that will help facilitate change and facilitate upgrade for our industrial users as we move forward. And it sounds like that's the direction that Scott's organization is going in recognition of that trend. And that's really the direction that Belden is going as well. We have developed our own industrial edge solutions portfolio comprised of our Hirschman OpEdge hardware, which provides edge compute encased within a network platform. And we have supplemented that with edge applications to support data ingestion and other runtime. And of course, I talked about our Belden Horizon platform earlier for the management and orchestration of the infrastructure. So we've realized this trend, this move towards virtualization and containerization, and we believe as well that that's the direction the market is going to go in. But of course, a lot of the driving motivators that I talked about earlier, the idea around ensuring that there is modularity in the installation and interoperability and the ability to support decentralization, all of these will also continue both in the short and long term as well. And it's a part of our strategy, and I anticipate that of others as well.
I'd make one comment, right? If 10 years ago to someone, hey, would you like to run that in a VM? They're like, what are you talking about, run that in a VM, yep. Right? But today, like, yeah, we got a whole data center set up. Can you just put that in here? Because that's where our compute platform is, right? So it's a very different world than it was not too long ago.
Absolutely. So speaking of that, and I think we've got a few minutes left here to wrap up. What initiatives do you see on the roadmap with your customers that they're going to be accelerating over the next 2 to 3 years?
Yeah, for us, I think it's pretty simple in that it's getting smaller. And Jeremy talked a little bit of this, getting, once you have your data and your analytics and your intelligence closer and closer to the devices, right? It's no longer just in the SCADA system or some off-plant, analytics platform. It's like, what do you do locally to handle that data, right? And so that's what we're going. And like I said before, rather than sitting big chunk at the DMZ, now I'm going to be able to segment and do things, at a device level and make it cost effective to do that. And so I think that's the biggest thing we're seeing is just moving closer and closer, more into the network itself and doing things there rather than just at the far edge.
Absolutely. Jeremy?
Yeah, and I'll borrow a comment that Scott made earlier about, in order to ensure that a pilot implementation is successful, there needs to be a clear recognition of the use case. And I think more than anything else, industrial users have become more adept at identifying the use cases that they need to address to satisfy some kind of business purpose or business objective. So with that recognition, it puts them in a position where they are more willing and able to undertake the efforts to develop these pilots and subsequent IIoT implementations to actually be able to do something with that data and derive valuable insights from it. And then everything else will fall into place thereafter, building that network infrastructure, building the edge compute layer, and so on and so forth to be able to realize that ultimate use case.
Great. Do you guys have any final thoughts or points that you feel like we didn't make or didn't discuss that would be interesting to bring up?
I guess, thinking about the use of the more generic use of protocols and how things are, I see the competition heating up, between just even like historian vendors, right? So OSI Soft, right? Pi owned the market, and now you see a lot more sort of, I want to say niche players coming into play, but there's a lot more diversity as things become accessible, right? As data becomes accessible, there's more people that are saying, hey, I can think of a clever way to utilize that data and make it and present it to the customer, right? And so we see our job as trying to facilitate, getting that data to the people who need it without creating any kind of threat against the plant, right? So how do you get that there? Everyone's got to move data, right? But how do you do it securely? And that's sort of our mandate.
Yeah, so it seems like both of you guys really are the sort of foundational layer that then allows all kinds of innovation on top of that, whether that's
right.
Bringing niche vendors or platforms that have a really great recipe or solution for a particular type of application using that IoT data, right? Whether
right.
that's a predictive maintenance solution or a certain type of, data collaboration platform for a type of users, right? You guys facilitate, and what's necessary for scalability in the future of any initiatives that you have with IIoT data is that the data itself is flowing the way that it should, and it's secure. Right. And then you can build all kinds of stuff on top of it, right? Yeah. Maybe something very basic, or, I think of it sort of, there's a lot going on in generative AI right now, like not the topic of this panel whatsoever. But we're seeing like a bunch of startups that they're not building the models themselves. They're building an application that uses the model to do something specific that, yes, maybe people could build themselves, but they figure out this really great use case and they know how to handle that really, really well. And this is a trend I've seen just in the industrial automation space in general. We kind of used to have this market that was dominated by a few big players, and they, went all the way up the stack, right? They kind of provided all the hardware, and then they also, all the way down to the historian and this and that. And they would oftentimes, I think, white label a lot of other people's things just to kind of keep everything,
Right. In-house. Yeah.
In-house, right? And this,
Yeah.
we realized that probably isn't the best way to scale and be resilient as an industry, from a lot of different perspectives, whether it's supply chain, or other things, right? And to see the emergence of these smaller kind of niche players that do something unique and do that really well. And I love seeing this too. I guess you when you have the larger players realizing that it's in their benefit to provide the infrastructure to let the smaller players also play in that sandbox, because that's really all to the customer's benefit, right? They can then choose what they need, and maybe get some of those specialty services or applications on top of something trusted, scalable, and resilient that they can work with, like from now to whatever else. Looks like we have some audience questions coming through. As well as some thoughts. Critical industries are soon going to be required to be quantum resistant. Oh, this is an interesting topic of conversation, quantum computing as well. Do you guys want to touch this?
I do not claim to be an expert in there, but that's one of the things. So it's sort of tangential, but we were talking the other day in the office about AI, right? And one of the things the AI is fantastic about it is sort of faking things, right?
Yeah.
And so so the problem is, right, that you start faking credentials, you start, faking, who people are, their identity, etc., right? And obviously that can pose a real problem with cybersecurity, right? And so that's one of the reasons we think at first we were like, geez, what is that going to do, to the idea around the cybersecurity? But then we think, well, hardware at the end of the day, right? It's only doing, it can't be sort of faked by AI, right? So we're thinking, okay, this actually makes sense, and we may end up with a stronger value proposition in that you can't fake hardware with artificial intelligence. So I don't know, we'll see, but yeah, and the whole quantum thing again, hardware sort of you can't recreate stuff that's missing, right? So while you can crack things faster and you might be able to do things with encryption and things, at the end of the day, you're still not going to be able to get into the plant, right? And that's where you want those turbines and pumps and everything that's going on there to make things continue to work. So
yeah, so I think we definitely all have to stay on our toes though, just for what's coming,
for sure.
whether it's in the hardware side of things or the AI side of things or software. Any thoughts there, Jeremy?
Well, the fact of the matter is everything we've talked about during the panel today has, in many respects, has been driven by the prevalence of lower cost computing capability. Yep. So long-standing trends like Moore's law, being able to fit more transistors on a chip and do so at a lower cost. This acceleration in computing capability with a complemented reduction in cost has really facilitated our ability to run these workloads in a virtualized or containerized manner in the first place. So as we continue to develop our computing capabilities in the industry further and further, it's just going to continue to accelerate our ability to essentially do more with less and address some of those challenges that I mentioned at the beginning of the panel today, that of the inflationary pressures and supply chain constraints. So essentially, it's just more of the same to accomplish our ultimate goals at a much more accelerated rate and in a cost-effective way.
Absolutely. Well, I think that's our time. So I would love to thank you guys for joining. I guess one last, I want to ask both of you, if somebody was in on this session today and wants to learn more either about what you guys are doing, OWL or Belden, or get in touch with you guys, you want to give a little plug for where they can find you, where they can, or if they just want to continue learning from you, do you have, how can they follow any upcoming events that you have, webinars, information? Give a plug for yourself before we throw up the thank you slide.
Sure. Yeah. So, I mean, our website, cyberdefense.com is, we've got a whole resource library. I think we have like 250 videos and white papers and use cases there for folks. And we have an active chat capability. So that's where we see a lot of people coming in first time and just saying, hey, let me find out more. So I would definitely start with it. Or you can email me, scoleman@owlcyberdefense.com. Glad to talk to anybody if they have questions.
Thanks.
Yes. I would also encourage any listeners that are interested to visit our website at www.belden.com. There's a lot of great product as well as solution-oriented content on there. And in particular, as Belden has really invested in transitioning from being a provider of products to one of solutions, there's a lot of new and very relevant content that we've added in recent months. We also have a very active blog that is present on the Belden website that is constantly being refreshed with new and interesting content as well. And of course, I would also invite any of you to email me at jeremy.friedmar@belden.com or connect with me on LinkedIn.
Great. And as for myself, again, Nikki Gonzalez, you can connect with me on LinkedIn. If you're interested in, if you listen to podcasts, you can find my podcast Automation Ladies on any of the, Apple, iTunes, Spotify. We also have a website, automationladies.io. We talk about this kind of stuff sometimes, but more so we talk to a lot of people on the plant floor, systems integrators, people like that. And we like to showcase all the different types of jobs that are in the, different plants in industrial automation. And then quotebeam.com is where I work, and we actually help people with the supply chain stuff. So whether it's, we don't specialize in chips, but we've helped some of these hardware vendors get some of the things they need to make some more hardware, as well as, panel builders and systems integrators and OEMs. We're really trying to connect that side of things up to help people, because the future really is about us working together, right? As a community, as solution providers, as end users, systems integrators. None of us can go at it alone. So thank you to Litmus for bringing us here together for this talk. And I think there's a lot of exciting talks planned for the rest of the day. And we're going to be concluding with a happy hour with Chris Lukey. So stay tuned, guys. Thank you so much for joining this session. And I think another session will be starting here in a few minutes for you guys. So thank you so much, everyone. Have a great rest of your day.
Thanks, everybody.
Thank you.